So this is approximately equal to, so we are going to substitute now in the expansion. It is 1 minus, where there's x, we are going to put 0.01 minus again 0.01 squared over 2, then minus 0.01 to the power 3 over 2. Okay. Okay, so now what is this expression here? The square So when we compute that, we're going to have square root of 2 is approximately equal to 1.413571. Okay. All right. Questions?
How did you find the approximation of the square root of 2?
At what?
How did you find the approximation of the square root of 2?
Haven't gotten you right. What are you really asking? Because everything I've written was to approximate the square root of 2. Maybe you might want to change your question a bit. What is your question again? At what was your question? Yes, Emmanuel.
Yeah, sir, I'm confused. Yeah.
Eh?
I'm confused on the second part where how is it going down?
How did what?
On the second last part, how 7 is moving from up to down.
Oh, so here we cross multiply. We multiply this. That's why we have said the 0 point multiply by 10. Then definitely you have to divide by 7 on both sides.
Okay, thank you, sir.
Yes, William.
Yes, sir. On how did you introduce the 100, 98 over 100? Like, how did the 100 came from?
0.98 as a fraction is what?
Oh, all right. I
0.98
get
as a
it.
fraction.
All right. Thank you, sir.
Yes, Tavo. Amon.
Yes, sir. How did the 10 come about again?
How did they?
The 10 come about since
The square
there.
root is everything. Remember the rules of SAT? The square root of a over b is the same as the square root of a over the square root of b.
Oh, okay. I remember.
Yes, Stephen.
Sir, and behind, how did you find that 0.01 you are replacing on X?
It was in the question.
Okay, sir.
It was in the question. The question is here. By substituting x is equal to 0.01, find the decimal approximation of root 2. It's in the question. Yes, Violet.
Sir, here, wait, just on the first step where you're saying 0.01 raised to the power 3. Down here, isn't it supposed to be 6 instead of 2?
What was your what did we find here? Here. What was it? Because it's coming from here. Expand this. There's an 8 this side, okay? Expand this. What is it going? What is it giving you? Sorry? Eh?
It's 2, sir.
Okay. Okay. I think at this stage you can solve any equation in the tutorial sheet, not so. Okay, so we are done with the trick. Yes, Hope.
Sir, in the tutorial sheet, there are questions whereby they tell you to prove certain. Let me say, for example, they tell you to prove n choose r plus n choose r minus 1 is equals to n plus 1 choose r. And then they tell you to prove that.
Okay.
Okay, so how do you go about it, sir?
You use the definition of factorials. You use, what is it? You mean proving the Pascal's rule?
Yes.
I had the Pascal's rule, but I didn't want to prove it for you. I felt it was not interesting. But since you've asked for it, so you are looking for the proof for n choose r minus 1 plus n choose r is equal to n plus 1 choose r, right? Right.
Yes.
So we are going to follow the definition of n choose r. So here we're going to have n choose r minus 1 plus n choose r is equal to n plus 1 choose r. This is the same as n factorial over r minus 1 factorial multiplied by n minus r okay, n minus r minus 1 factorial. This is for this one, okay? This is for this one. Then plus n factorial over r factorial n minus r factorial. So you've expanded it first. Then the next thing you're going to do is you're going to find the lowest common denominator. Okay? That is one way. You're going to find the lowest common denominator. Let me go in a naive way. I think like a student. Let me do this before I go any further. This implies n factorial over r minus 1 factorial n minus r plus 1 factorial plus n factorial over r factorial, then n minus r factorial. Let's find the common denominator here. Okay. Note that n minus r plus 1. So this is what you should notice. As quantities, this one is bigger than this. Let me use another pen. Do you agree with me that n minus r plus 1 is bigger than minus r? This one is bigger than that, right? So we're going to write this one in the denominator. We're going to write n minus r plus 1 factorial. then r is bigger than r minus 1 factorial. So we're going to write r factorial here. Okay. Then we're going to say this into that. This into that. Okay? In short, you are saying, let me use another ink so that you just start thinking the same way. So this into that, in a sense, you are saying r factorial n minus r plus 1 factorial divided by r minus 1 factorial, then n minus r plus 1 factorial. Definitely this goes, right? Then now you're going to remain with r factorial over r minus 1 factorial. But if you look at this one, what are you going to remain with? R factorial is the same as r multiplied by r minus 1 factorial over r minus 1 factorial. So this and this cancels. So this whole quantity into that is r. Then r multiplied by n factorial, we write r factorial multiplied by n factorial. This is for this one on the left. Now let's do for this one, this side. So we are going to say the same thing here. This one into that, in a sense, you are saying r factorial n minus r plus 1 factorial divided by r factorial, then n minus r factorial. So this and this cancels. So I remain with n minus r plus 1 factorial over n minus r factorial. Again, you're going to look at the one on top. The one on top is bigger. So this is the same as n minus r plus 1 multiplied by n minus r factorial, and everything over n minus r factorial. So this and that cancels. So this into that is n minus r factorial, n minus r plus 1. So then we multiply this to this, so we're going to have n factorial, then you're going to write n minus r plus 1 factorial. Oh, there's no factorial at the end, sorry. There's no factorial for this one, then the sign is plus. Okay. And my apologies, here r, not r factorial, found r. Normal expansion. You're going to have r n factorial plus n minus r n factorial, then plus n factorial, and everything over r factorial, n minus r plus 1 factorial. As you can see now here, this cancels with that, right? Then you remain with n multiplied by n factorial, then plus n factorial. Okay, so you need to know and understand how the factorial behaves. So on top, we are going to have, let's factor out the n factorial. When factor out the n factorial on top, we factor out the n factorial out, then inside, because we're looking at this and that, okay? Because these two cancelled. So you remain with the n plus 1, then over r factorial, then n minus r plus 1 factorial. Now, n factorial multiplied by n plus 1 is just the same as n plus 1 factorial. So this is going to be equal to, on top is going to be n plus 1 factorial, because n multiplied by n plus 1 is n plus 1 factorial. Then again, the denominator will be over r factorial n minus r plus 1 factorial. So now what is this equal to? We have this fraction, n plus 1 factorial over r factorial n minus r. So this is going to be equal to, if you look at it, this is going to be equal to, on top we are going to have n plus 1, then in the bottom we are just going to have r, because when you expand this, it will give you that. That's how we do it. It's okay.
Thank you, sir.
All right, so that's it. I'll share these notes. We can now move to trigonometry. Are you getting me clearly?
Yes, sir, we are getting you.
Yes, sir.
You sound very humble. Tell me, why are others not making it for classes? What is happening? Someone to tell me?
Lack of bundles, sir.
They don't have money for bundles.
You guys, didn't you get BC recently?
Network.
No.
No, we
Eh?
did not.
This is the second month not getting it.
Some of us were on self-sponsorship.
But you guys, okay, those who are on GRZ sponsorship, you didn't get your meal allowances.
No, we
No.
did not.
didn't, sir.
No, we didn't, sir.
It's next month. I don't know. They were supposed to release this month, but they changed their minds. I don't know what really happened with that. It's next month, the 1st of June. So we'll receive together with for this month, for May, and for June next month.
Oh, sorry. So the issue of bundles is a very serious one, eh?
Yes, sir.
Yes.
1 plus 1 GP.
You know, sometimes it's very hard to look at things from a student perspective. I don't know. We stopped the classes. Teaching less than half of the class. Am I audible?
Yes, sir. You're audible.
Yes, sir. You're audible.
Yes.
So I was asking to say, should I stop the classes here? Because I'm just teaching less than half of you.
No, sir, you shouldn't stop.
We have to make progress, knowing that the time is moving.
How are you doing catching up?
Can it be possible if you be uploading the videos on YouTube, like the way our chemistry lecture is doing, uploading them on YouTube after a lecture so that others will be able to access them even after class?
Me, YouTube. YouTube.
No, you're suggesting YouTube. You're complaining about bundles. Don't you need bundles to operate YouTube?
We can't even learn mathematics on YouTube because we need to be asking questions.
Okay, let's proceed. We are done with binomial, so we can move to trigonometry now.
So how many topics are remaining before we conclude the whole syllabus?
There are many. We still have a long way to go. What we've covered is only 40% of the course. In fact, 30%. We are remaining with 70%. Okay? Don't start crying.
Well, okay, sir.
Okay, let's turn our new. Trigonometry is not new. You met trigonometry just okay. So trigonometry is what we are looking at. Trigonometry is not new. You've made trigonometry in high school. You did quite a lot of things in high school. Now we are just going to build up from where you ended. But first, we'll take you back a bit. When we're dealing with trigonometry, it's either you deal with degrees or radians. So let's start first by discussing the radian measure. What is the radian measure? So you measure angles using degrees, but the radian measure is another measurement for angles. So the radian measure is another basic unit of angle measure. Angle measure that will be used in this course. Okay? We define one radian to be the angle subtended at the center of a unit circle by a unit arc. by a unit arc. I'll explain this. Arc length on the circumference. I'll explain this just in a bit. On the circumference. On the circumference. So what do we mean here? We mean this. A unit circle is just a circle of radius 1, okay? So it's a circle which has, you should pardon me, the drawing isn't so good. I hope this is not worse. So this circle has radius 1. So here you have 1, there you have 1, there you have 1. So 1 radian is equivalent. So this is 1 radian, which we just write as 1 rad, is equivalent to this angle subtended by 1 unit. So this circumference, the distance from here to there is 1 unit. Okay? So it is the angle subtended at the center of a unit circle by an arc length of 1 by a unit arc length on the circumference. Okay? So this is 1 radian. So now when you think about it, since the full circumference of a unit circle. What is the length of the circumference of a circle? Is the circumference of the circle, the perimeter of the circumference of the circle is 2 pi r, right? But here r is 1, so it will just be 2 pi units. We have the following. 360 degrees is equal to 2 pi radians. So we can divide by 2 on both sides, or equivalently, (180 degrees is equal to pi radians. So this relationship can help us to juggle between degrees and radians. Degrees and radians. This relationship that we've put here. Okay. So let us look at the conversion. We just write the compact form. Conversion between degrees and radians. So because 180 degrees is equal to pi radians, 1 degree is equal to pi over 180 degrees, and 1 radian is equal to 180 degrees over pi. Okay, let's look at an example. We look at the conversion. Example, convert 30 degrees and 45 degrees to radian measure. Solution. So 30 degrees is just equal to 30 degrees multiplied by pi over 180 degrees. So this will be 30 degrees over 180 degrees pi, and this will just be pi by 6. So we've converted the 30 degrees to radians. Similarly, 45 degrees is equal to 45 degrees multiplied by 180 degrees, which is 45 degrees over 180 degrees pi. And this is going to be equal to pi by 4. Are we okay up to there?
Yes.
Yes, sir.
Okay. Okay. Let's see now. What if you have an angle in radians? You want to get the angle in degrees. Sine ratio. Sine ratio is defined by sine theta is equal to opposite over hypotenuse which is equal to A over C to cosine ratio is defined by cos theta is equal to the adjacent over hypotenuse which is equal to B over C, and finally 3 tangent ratio is defined by tan theta is equal to opposite over adjacent, which is equal to A over B. Okay, I think we can end here for today. So I don't think we should meet tomorrow. We've already met 3 times. I thought we were very behind. Other than when we have a tutorial, we are going to meet 4 times. But I think tomorrow you better rest. And encourage everyone to try to attend classes. Because if we attend so many classes, others are missing, it will be very chaotic. Yes, Izukanji?
Sir, so the suggestion, maybe instead of just missing out on tomorrow's class, why can't we just probably cover the tutorial sheet together?
It's not really missing. I have an engagement tomorrow. Maybe next week.
All right, sir. Thank you.
Okay, let's end here. Have a pleasant rest of the day.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you so much.
Jesus loves me. Jesus loves me. Little hands, little heart, used to call.